Hello everyone, welcome to another lecture on factoring polynomials. And here we want to focus on factor theorem extended. This is the continuation of the other lecture I gave on factoring polynomials. The ones that we discussed in the past were polynomials where the leading coefficient were always equal to 1. But in this case, in this lecture, we are discussing polynomials where the leading coefficient is not equal to 1. Okay? For example, we have 3x cubed minus 19x squared plus 27x minus 7. It's a cubic polynomial. We want to factor it, okay? But the leading coefficient is 3 and it's not equal to 1 like it was in the past. So we are using factor theorem extended. What does it state? It says a polynomial function of f of x equals a sub n x to the n plus all the way to a sub 1x plus a sub 0 has a factor of px minus q. Px minus q if f at q over p is equal to 0. Over there in factor theorem we said that it has a factor of x minus a if at a is equal to 0. Now you're saying it has a factor of px minus q if f at q over p is equal to 0, where p, which is the denominator, divides a sub n, which is the leading coefficient, and q, which is the numerator, divides a sub 0, which is the constant term in the polynomial. That's what factor theorem states. In the example, we have a cubic polynomial. We want to, of course, factor it. So this time, we're not looking for the divisors of the constant. Why? Because the coefficient of x cubed is 3, or it could be something else other than 1. So in these cases, what we do, we are looking for fractions of the form q over p. We don't look for like an integer like a. Now the numerator, which is q, according to the theorem, should divide a sub 0. So divisors of -7 are plus minus 1 and plus minus 7. We write them down in the numerator. And then the denominator must divide the leading coefficient, which is 3 in this case. So what are the divisors of 3? Plus minus 1, plus minus 3. So now these are all the fractions that we need to consider. And we are hoping that f at one of these fractions, q over p, will be equal to 0. And then according to this factor theorem extended, they can immediately announce that px minus q is a factor of this polynomial. So we have to consider all the combinations, 1 with 1, 1 with 3, 7 with 1, 7 with 3. So we end up with plus minus 1, plus minus 7, plus minus 1/3, and plus minus 7 over 3. So here we have like 8 candidates, okay? We have to check to see f at which one of these candidates will hopefully be equal to 0. So we try with f at 1, for example, we pick 1. And when we find f at 1, let's plug in, we get 3 minus 5, 3 minus, we end up with 3 minus 19, okay, and then plus 27 minus 7. So that's 20, that's 1 and 3, it's equal to 4. If you find f at 1, using mental math or calculator, you get 4. Now, 4 is unfortunately not equal to 0. That means that x minus 1 is not a factor of this cubic polynomial. We continue our search with another value, let's say -1. So f at -1, when we plug in, we get -3, -27 minus 7, which is some negative number, but it's definitely not equal to 0. So we try another combination. 1 and -1 didn't work. We don't lose our hope. We continue in our search. We try 1/3. So f at 1/3, we get 1 over 9 minus 19 over 9. You plug in, plus 9 minus 7. Guess what? We end up with 0. So happily, we announce that f of x is divisible by what? Divisible by px minus q. That is 3x minus 1. Or 3x minus 1 is a factor of f of x, in other words. So if it's a factor, the remainder must be 0. We divide it, but we don't want to perform long division because it's time consuming. Therefore, we are going to use what? Synthetic division. So write the coefficients like we have done several times in the past. You have done it in your homework questions many times because I'm confident and I'm sure that you are all interested students and you have practiced a lot, and it's not the first time you see something like this. So bring 3 down, multiply by 1/3, and where did 1/3 come from, by the way? It is the root of the divisor, okay? So 3x minus 1 set it equal to 0, solve for x, you get 1/3, root of the divisor. So 3 times 1/3 is 1, add them up, -18, times that -6, add them up, 21, times 1/3 is going to be 7, add them up, 0. As we expected, we ended up with a remainder of 0. So the coefficient we have is 3x squared minus 8. The quotient will be 3x squared minus 18x plus 21. These are the coefficients, of course. And here we have to multiply by x minus the root of the divisor, x minus 1/3. In the process of synthetic division, in the past we said that it always has to be x minus k, when you're dividing, when you're using this synthetic division. Now the thing is that 3 is a common factor. I can factor it out. So I get x squared minus 6x plus 7. And I can easily multiply the 3 by the first binomial. So using distributive law, I'm going to get 3x minus 1. This is the factor we were looking for. And here we have x squared minus 6x plus 7. Now the question is, can we factor this quadratic trinomial? Can we find two numbers that add up to -6 by the product is 1? The answer is no. I don't think so, because the product is positive. So either we should get 1 and 7, which adds up to 8, or -1 and -7, which adds up to -8. But never it would be -6. So therefore, this quadratic trinomial is not factorable. It's not your fault. And the very final answer to the question would be what you see in front of your eyes. So that cubic polynomial with a coefficient, leading coefficient that was not equal to 1 will be factored as this expression as I showed you here. Now, if the degree is 4, 5, 6, whatever, the whole procedure is repeated. It will be a little bit longer, but not harder. So here there is an example. There's an exercise for you. 3x to the 4 minus 5x cubed minus x squared minus 4x plus 4. It's a quartic polynomial. The leading coefficient is not 1. Therefore, you have to use the factor theorem extended. And the q over p fractions, I have written it briefly, but that's just for your checking of your answers. It will be plus minus 1, plus minus 1/3, plus minus 2, and so on and so forth. And the final answer will be this expression right here at the bottom in fully factored form. Hopefully, you will be able to do this question by yourself, following this model. After you review this several times, after you redo this by yourself, after the whole thing makes sense for you, I'm sure you're going to try this question as well as your other questions. This is just another example here. 6x to the 4 minus 17x cubed plus 7x squared minus x minus 10. And the final answer would be what is on the board right there. So two exercises for you to practice and become better and better at the use of this factor theorem extended. Okay, so I hope you found the lecture helpful, and I hope you are going to practice and become better and better at factoring polynomials. Mind you, this is not an easy thing. In the past, in junior grades or even grade 11, you could never, factor a cubic polynomial, a quartic polynomial of this type. You could never factor it. You didn't know how to do it, but now thanks to factor theorem and factor theorem extended and your knowledge of grade 12 math, you can factor all sorts of polynomials. Thank you.